right, so today we're going to take a look at how to solve quadratics by factoring. There's going to be 5 ways total. We've already looked at how to solve by graphing and by using the square root method. Obviously, today we'll do factoring. And then the 2 others, quadratic formula and completing the square, that will come in upcoming lessons. But before we get into solving, we need to remember how to factor. So I'm giving you this slide. It is a reminder slide. I gave this to you in the beginning of the school year when we went over factoring in the summer packet. So just again, remember, always look for a GCF first. Then, depending on how many terms we have, will be our way of factoring. Okay, so you always have reference to this if you need it. Now, if you're struggling with factoring, I need you to reach out to me. I can get you the help, either other videos, practice problems, or set up a meet with me. So that way we can go over and make sure you know how to factor. Factoring is going to be really important as we go through a lot of Algebra 2. Okay. So first things first, solving by factoring, you use what's called the zero product property, which states if A times B equals 0, then A equals 0 or B equals 0. Okay. Again, basically knowing the fact that anything times 0 is going to be 0, that just means one of your factors is going to be 0 then. So the way we do this is we set all factors equal to 0, and then we solve it. And important, you have to set the whole equation equal to 0 before you can do anything. So I have 2 equations done here. The one on the left-hand side, x squared plus 6x plus 8, simple trinomial. Factors of 8 that add to 6 are 2 and 4. It's a 1 as my leading coefficient, so I can use a shortcut and just make it x plus 2 and x plus 4. And then you can see here, I simply just took each individual parenthesis and I set it equal to 0. And there's my 2 solutions. Okay, the second one is just one that didn't have a coefficient of 1, just to show you that process again. Also, if it gives you function notation or y equals or whatever, you make sure it equals 0 first. So you can replace your function notation with 0 before you start factoring. So I looked, these had nothing in common, 2, 11, 12, there's no GCF. So I start my diamond method, A times C, so 2 times 12 is 24, that's my top, has to equal or add to the middle term, which is the bottom, negative 11. So negative 8 times negative 3 is a positive 24. Negative 8 plus negative 3 is a negative 11. I split that middle term to my factors, and then I group. First 2 have a 2x in common. Last 2 have a negative 3 in common. The goal, remember, is to get these groupings to be identical. So that way you can take it out and then put the GCFs in their own grouping. Again, from there, just like in the first problem, you take each individual parenthesis, set it equal to 0, and you solve it to get your 2 solutions. And that's going to be your solving by factoring. So let's take a try. I'm going to do one of the top rows and one of the bottom rows with you. Again, first things first, if it does not equal 0, you need to get it to equal 0 first. So I'm going to do C with you. So first thing I'm going to do is move this over by subtracting. So I'm left with 3x squared minus 5x minus 2 equals 0. Now I have to look, 3, 5, 2, there's no GCF there. They all don't have an x, so again, no GCF. So I'm going to start by doing my diamond method. So I'll do that up here. Multiply 3 times negative 2. That gets me a negative 6. So again, I just multiplied the a and your c constant. Has to add to the middle term, which is negative 5. So values that multiply to negative 6 that add to a negative 5 would be a negative 6 and a positive 1. So that's what I'm going to split this middle term to. I'm going to leave everything else the same. Drop down the first, drop down the last. And then I'm going to group it. So first 2, they have a 3. I can divide them both by 3 and an x in common. So I'm going to take that out. And I'm going to be left with 1x, right? 3 divided by 3 is 1. X squared, take x away, is an x. minus 2. 6, negative 6 divided by 3 is negative 2. X taken x away no longer exists there. Then we're going to take a look at the second 2. Well, they have nothing in common. And x minus 2, there's nothing in common there, but I can take a 1 out. I have to take something. You have to take a grouping out some way. And with doing that, sure enough, I get the same groupings. I get the same sets of parentheses, which is what I wanted to have. Once I have that, I can then write this as x minus 2, and then 3x plus 1 equals 0. So that's my fully factored form. Now to finish off this problem, so I have room on the right, I'm going to go over here. I'm going to take each grouping, set it equal to 0. So x minus 2, that was my first set of parentheses, and 3x plus 1 was my second set. And then you simply solve it. I add 2 on the first one. That's my first answer. I would subtract 1 and then divide by 3. And there's my second answer. Okay, so that's how we're going to solve by factoring. Now, part E, F, and D, I put them backwards. Oops, my bad. But we're still going to do it the same way. We want to first replace the f of x as 0. And then I can write out the rest as is, because I want to find the roots. Again, finding the solution, finding the roots, finding your intercepts, they all mean the same thing. And now I want to try and factor this. So looking at the problem, x squared minus 8x, well, they both have an x in common. So I'm going to take that out. If I take an x out, that's kind of hard to read. Let's do a different color. If I take an x out, x squared with an x taken away is just x. Negative 8x with an x taken away is a negative 8. Oops. And then again, I would just simply solve these. I can't factor it any further. Now, some people see this and get a little worried, but just note that x is a factor, and so is x minus 8. So when I go and solve this, one of them is x equals 0, and the other is x minus 8 equals 0. Well, there's nothing to do here. That is my answer with the GCF in that part. And then the other one is x equals 8. Okay, so again, as you're going through this, just because you have a single term, you have a GCF out front, doesn't mean you can't set it equal to 0. That is part of a solution. It is part of your factor. So you do need to include that when you are going through and finding your solutions. Okay. Let me just finish erasing this, and then we're going to move on. The one last thing we're going to take a look at in factoring, or using factoring, is we can go backwards. I can give you the solutions. I can give you the zeros, the roots, whatever it is they're calling them. And I can then come up with the equation it came from. Okay, so I can use the fact that I know that, for instance, before I erase this, x equals 8 came from an x minus 8 to help me out. Okay. So let's move on to the next one. So here's what I was talking about. If I know the zeros, if I know the solutions, I can go backwards. Okay, so just like I said before, x equals 8 came from an x minus 8. X equals 11 came from an x minus 11. It always comes from the opposite of the solution. So once I'm here, I'm just going to FOIL it. X times x is x squared. X times negative 11, negative 11x. Negative 8 times x is negative 8x. And 8 times 11 is 88. And then you clean up and combine your like terms. And this would be the function where those two answers came from. Okay, we will be going through those problems in the lesson, but you have at least that one worked out for you. And we'll also get into applications and word problems of how to solve for patio extensions, the carpet on the previous one, or anything else that needs to be solved using quadratics.